All right, so in this section, section 4, chapter 8, we're talking about adding and subtracting rational expressions with unlike denominators. So what I'm going to do is I'm going to give us a little example from like the past, a blast from the past, if you will. So here's our example right here. So let's say I wanted to add 7 over 12 plus 5 over 18, okay? If I can write an 8, that'd be great. There we go, 18. So we remember that in order to add fractions with unlike denominators, we need an LCD. Now, I know there's a lot of different ways we can do this, but I like to do it the very old school, very simple, visual way, so I know exactly what I'm dealing with. So here's what I'm going to do. I'm going to write the number 12, and I'm going to break this down into its prime factorization. So if you forget how to do that, all you need to do is just think about the number 12 and ask yourself, what are two numbers that multiply to get 12? It doesn't matter what they are. I'm going to say 2 and 6. Now, 2 is a prime number, and 6 is what we call composite numbers, so that can be broken down into 2 times 3. So 12 is going to be 2 times 2 times 3. Okay? And I'm going to do the same thing here with the number 18. So 18 is going to be 2 times 9. 2 is prime. 9 is 3 times 3, and those numbers are both prime. So I guess I'll just circle them. So 18 is going to equal 2 times 3 times 3. Now notice the spacing here, because that's really important. Organization is the key. So my LCD is going to be just draw arrows straight down. That's all you got to do. And just copy the number. So 2 times 2 times 3 times 3. And when you multiply these numbers together, you get 36. So my LCD for this problem, 7 over 12 plus 5 over 18, is 36. Okay? So I would consider this step number 1. All right? Step number 2, what I would do next is I would build equivalent fractions. Okay? Now, I know I'm starting with the fractions 7 over 12 and 5 over 18. These are the two numbers I'm starting with. My goal is to create a fraction for each of these such that the denominator is a 36. Okay? So I need to multiply both of these fractions by a number that will give me 36 as my denominator. And here's the key. Okay, here's the key. You are building equivalent fractions, which means the only number you're allowed to multiply by, in this case right here, is going to be, now I'm going to write this, but then I'm going to erase it. You'll see what I mean in a second. So the only number we can really multiply by is 1 over 1, okay? But we can be really clever on how we write that number 1, all right? For example, we know 1 over 1 is 1. Off to the right-hand side, 2 over 2 equals 1. 8 over 8 equals 1. 10 over 10 equals 1. So we can choose any value we want as long as that number is the same in the numerator and denominator. So if you just give me a second here, I'm going to copy down that LCD again because I want us to see it. All right, so I just paused the video so I can copy down my LCD again because I want us to see something. All right, because this is the key to this entire process that we're going to be doing. If I'm already starting with the number 12, I know 2 times 2 times 3 equals 12. The only number that I'm missing in my LCD is that number right there, that 3. So what I'm going to do is I'm going to take that 3 and just copy it down here. Now, if you look, 12 times 3 is 36, and 7 times 3 is 21, okay? Now, I'm going to do the same thing with the 18. Notice that 2 times 3 times 3 is 18, okay? So that means I already have the 18 right here. The only number that I do not have highlighted is that number 2. So I'm going to take that number 2 and write it as 2 over 2. Now, note, 18 times 2 is 36, and 5 times 2 is 10. So right here are going to be my two equivalent fractions, 21 over 36 and 10 over 36. So step 3 in this process would be to combine and simplify. And what I mean by that is 21 over 36 plus 10 over 36 is going to equal one big numerator as 21 plus 10 all over the denominator 36, and 21 plus 10 is 31 over 36. Now, 31 is a prime number, so I don't have to worry about simplifying anything. So there's my final result. So if we can keep this process in our head, adding or subtracting rational expressions with unlike denominators is very, very, very simple. It is just literally this process all over again. Okay? Now, like I said, I know a lot of us back in the day, you were probably taught this, and there's nothing wrong with this. You were taught find an LCD between 12 and 18, and the LCD would be 36, but you'd have to do all that mental math. See, I don't do any of the mental math. I write it all out. But if you did this mentally, you would say, okay, well, I need to multiply these fractions by 3 over 3 and 2 over 2, and that's going to give me 21 over 36 plus 10 over 36. See, the only thing I do is I just break it up. I make it look a little bit easier. I give the process 1, 2, 3 steps, where what you're doing, what you were taught a long time ago, which isn't incorrect, is doing all 3 steps at once. I like to slow myself down with this stuff. All right, math is already hard enough. Why do I want to make it harder? Okay, and also if you notice here, and I'm going to highlight it in blue, this 3 over 3, well, it's staring you in the face. It's right there, and that 2 over 2, that's also right down here. So I'm doing the same thing. I just broke it up into steps. I like to logically think through something, not just jump right into the deep end. All right, so if that's the case, then what we can do is we can take this idea, all right, and then we can start adding and subtracting rational expressions with unlike denominators. So here's my example that I want to do. Okay? Now, if you want, I would suggest this. Just watch the video. Don't write anything down. You can always rewind. Okay? So we're going to simplify 8 over x squared minus 2x minus 3 plus 3x over x squared plus 4x plus 3. Okay? Now, like I said, if you're just watching the video, that's what I would do. I wouldn't write any of this down. Like I said, you can always just go back and watch it again and write it. So previously, our step 1 was we needed to find an LCD. So that's what I'm going to do here. And the way that we did this, even in this simple problem, prime, and here's the key word, factorization. We factored the numbers into prime numbers. That's exactly what you did. So with my problem, step 1, I'm just going to factor the denominators. So by factoring x squared minus 2x minus 3, that's going to equal excuse me, x squared minus 2x minus 3 factors down into x minus 3 and x plus 1. Now I will do the same for the second denominator. So that's going to be x squared plus 4x plus 3 equals, now that's going to be x plus 3 times x plus 1. Okay? Now, what I should be doing is this. I'm going to write that x plus 3 all the way over here. Because remember, as above, what I'm concerned with are all the factors that come straight down. So that's going to come straight down. This is going to come straight down. And then this is going to come straight down. And what you've just found is the LCD. Okay? So there's step one. Now, step two, we're going to build equivalent fractions. Just like we did previously. So what I'm going to write is 8 over x squared minus 2x minus 3. And my goal is to have this denominator look like this. My goal is to get a denominator of x minus 3 times x plus 1 times x plus 3. Now, here's the thing. All right, and this is why I'm hoping you're writing this down, or you're not writing this down, is that I'm going to rewrite this x squared minus 2x minus 3. I'm going to rewrite that as its factored form. And hopefully now, especially with that previous example, you could see why I'm doing that. Because if you compare, notice you have an x minus 3, and the LCD already has an x minus 3, so you don't need it. You also have an x plus 1, and the LCD already has an x plus 1. The only thing that you don't have is this x plus 3. So what I'm going to do is I'm going to write x plus 3 with parentheses around it times x plus 3. Or I'm sorry, x plus 3 over x plus 3. I said times by accident. So now, notice you have the denominator that you wanted. The only thing you need to write is 8 times the quantity x plus 3. So here's our first equivalent fraction, okay? Now, we're going to do the same exact thing again, except we're going to do this for the second fraction. All right, so I'm back. So all I did was I just cleaned some stuff up. All right, so like I said, we're going to do the same exact thing here. I'm going to use the color red again. So what I did is I rewrote my denominator in its factored form, the x squared plus 4x plus 3. That's the quantity x plus 1 times the quantity x plus 3. But my goal here is to multiply by some factor of 1 such that I get x minus 3, x plus 1, and x plus 3 in my denominator. Well, if you think about it, I already got the x plus 1. Check. I already got the x plus 3. Check. The only thing I don't have is the x minus 3. So, in blue, I'm going to write x minus 3, put it in parentheses, and x minus 3. So that's going to give me 3x times the quantity. X minus 3 is my numerator. All right, so now we got our two equivalent fractions, which is what we needed. So now, step 3 is just to, I'm gonna put the words rewrite and simplify. Okay, so let's go ahead and let's rewrite this. 8 times the quantity, x plus 3, all over x minus 3 times x plus 1 times x plus 3 plus 3x times the quantity x minus 3 all over x minus 3 times x plus 1 times x plus 3 is going to equal now, and I know this is a lot of writing, but it's not hard, it's just a lot of writing. So I'm going to write one big denominator and write one big numerator. Notice I've done 0 simplifying so far. All I'm doing is just rewriting things. All right, there we go. Okay? So from here, you need to simplify the numerator. Okay? So let me highlight that so you know exactly what I'm talking about. There we go. So we need to simplify this right here. So that denominator is not going to change. So let's just write that real quick. Now, let's distribute 8 times x is going to be 8x. 8 times positive 3 is plus 24. 3x times x is plus 3x squared. And then 3x times negative 3 is going to be minus 9x. Now that denominator stays the same. I'm going to group any like terms and just write it in descending order. So I get 3x squared out front. I get 8x minus 9x, or minus x, in the middle. And then lastly, I get 24 for my constant. All right, now we got one more additional step. And that's right here. It's still in that numerator. And you need to ask yourself this question right here. So I'm going to write it down so you know exactly what to ask yourself. Can you factor this? Okay? Because remember, we still got to simplify. And simplifying doesn't just mean combining like terms. It means combining like terms, factoring if you can, and then reducing any fractions or any rational expressions that you may have. All right? So for simplicity, I'm going to tell you, no, you cannot factor this. All right? Because I'm not too concerned with that right now. What I was really concerned with is just getting this answer and understanding, and I'm going to zoom out here, and understanding these 3 steps. So let's go over those steps just one more time, and let's highlight them so we're aware. Step 1, factor denominators. Step 2, you want to build these equivalent fractions. Step 3, you're going to want to rewrite and simplify. Every single one of these problems is going to be done the same exact way. I am not going to deviate at all from this method. Okay? The only way that these problems get difficult or more difficult is they just become more complex with the factoring. All right? But it's very straightforward. Okay? So let's work with a couple more. All right, so here's our next example. So what we're going to do is we're going to add. Now, I promise this one is going to be much easier than the previous one. Okay? So we're going to add 3 over x minus 3 plus 2 over x minus 2. Okay? Step 1, we're going to find the LCD. So x minus 3 cannot factor, and x minus 2 cannot factor. So notice how I staggered them here. My LCD is going to be the numbers coming straight down. So it's going to be x minus 3 times x plus 2, and that's it. So even though you couldn't factor, you still get an LCD, okay? Step 2, we're going to build equivalent fractions. So I start with 3 over x minus 3. I'm going to multiply this by something so that I get x minus 3 and x plus... Oops, sorry. I wrote plus by accident. This is supposed to be a minus. Hopefully you're sitting there going, oh, you made a mistake. Let me just fix this real fast. All right, there we go. So my goal is to multiply 3 over x minus 3 by something so that I get x minus 3 and x minus 2 in my denominator. Well, if you look, you already have the x minus 3. You don't have to do anything with that. What you need is that x minus 2. So I'm going to put x minus 2 over x minus 2, and then my numerator is going to be 3 times the quantity x minus 2. Don't distribute, don't do anything, just rewrite it. Okay? Now for the second example, or the second fraction, I mean, we have 2 over x minus 2. I'm going to multiply this by something such that I get x minus 3 and x minus 2 in my denominator. You already have the x minus 2's, so you don't have to worry about that. What you need is the x minus 3. Therefore, I'm going to write x minus 3 and x minus 3. So that's going to give me 2 times the quantity x minus 3. All right. So step 1 is done. Step 2, building the equivalent fractions, is done. Step 3, it's going to be rewrite and simplify. So I write 3 times a quantity, x minus 2, all over x minus 3 times x minus 2, plus 2 times a quantity, x minus 3, all over x minus 3 times x minus 2. And that's going to give me one denominator, because now they're the same, and one nice numerator. Notice I did not distribute anything. I'm just rewriting. You don't understand how much that is going to help you later on. So please be disciplined, be strict with yourself, and write these steps out. So now I can go ahead and distribute the 3, and I'll distribute the 2 as well. So that's going to give me 3x minus 6 plus 2x minus 6 all over x minus 3 times x minus 2. Now, when I combine like terms, I'm going to get 5x minus 12 all over x minus 3 times x minus 2. And I look at my numerator, and I ask myself, can I factor that? And the answer is no. There's no GCF. This is not difference or squares or cubes or anything like that. So just put a big square around it or a circle and type it in, and just be careful. That's it. So that's how we do these. All right. So let's look at some more complicated ones, okay? Let's try this one here. We're going to add 5x over xy minus y squared plus 2x over x squared minus y squared. Okay? All right, so step 1. Find the LCD. Now remember, you're going to take the denominators and factor. So my first denominator, I can definitely factor out a y. So that's going to give me y times the quantity x minus y. Okay? For the second denominator, well, that is going to be difference of squares. So I get x minus y times x plus y. Now my LCD in this case is going to equal, and remember, you got to come straight down, y times the quantity x minus y times the quantity x plus y. Okay? So here's my LCD. Now the goal, step 2, is to build equivalent fractions. All right? So let's start with the first one. So the first one was 5x over, and remember, write its factored form. So 5x over y times the quantity x minus y. We know we're going to multiply by a fraction so that we get y times x minus y times x plus y in my denominator. So take a minute, pause the video, think about what it is, and what you should have come up with is x plus y over x plus y. Now, if you're asking yourself, well, how did I know that? You got a y, you got a y. You already have an x minus y, you already had the x minus y. The thing you were missing is that x plus y. So that is why we chose x plus y over x plus y. Now remember, just be very, very disciplined and just rewrite it, okay? Now for the second fraction, that was going to be, that was 2x over x minus y times x plus y. Now remember, we want to get a denominator of y times x minus y times x plus y. So the only thing we have to multiply this fraction by to build an equivalent fraction is the variable y, because you already have the x minus y and x plus y. So in the numerator here, oh, maybe I should write this in red, because I've been writing everything else in red. So that's what I'm going to do. Keep it nice and consistent. Y over y, so this is going to be 2xy. All right, now from here, step 3, we're going to rewrite and simplify. Okay? Now, if you get sick and tired of writing out this big denominator every single time, here's what I would do if I were you. First thing I would do is just write the two fractions just like I was supposed to. So just let me catch up here. And then what I would do, okay, is I would just write the words LCD, because you already know what the LCD is. It's right there in purple. All of our work is going to be inside of that numerator here. Okay? So I'm going to go ahead and distribute the 5x. So I get 5x squared plus 5xy plus 2xy. Okay? Now when I combine like terms, that's going to give me 5x squared plus 7xy all over my LCD. Now, if I look in the numerator, I mean, technically, I can factor. So let's see, I can factor out an x to give me x times the quantity, 5x plus 7y, and I'm going to just write out that denominator again. And the reason I do that is I'm hoping that I have things that are the same on the top and bottom. In this situation, I don't. So there's nothing I can do about this. So nothing reduces. I circle my answer, and I just move on from there. All right? So now, in this situation here, in the next example, I mean, you're going to see why it is so important that we write out these steps. Okay? So here's a pretty straightforward one. We're going to subtract y over y plus 4 minus y over y minus 5. Okay? Now, what makes this problem different from all the other ones is right here. That middle sign is negative, and that changes. Well, let me be honest with you. It doesn't change the game. It doesn't change your technique at all. It's just you got to be super careful. And I will tell you when we get there why. So step 1. Let's find the LCD. So y plus 4 cannot be factored. Y minus 5 is different, so I write it off to the side, and that can't be factored. So my LCD is going to be y plus 4 times the quantity y minus 5. All right, so there's step 1. Step 2, we're going to build equivalent fractions. So I write y over y plus 4. Let me write that cleaner. Now I know my goal is to multiply by a number so that I get y plus 4 and y minus 5 in my denominator. So what I'm going to multiply by, and keep everything consistent with the coloring, is y plus 5 over y plus 5, and that's going to give me y times y plus 5 in my numerator. Okay? Oh, geez, I made another mistake. Oh, thank God I have the comments turned off in my YouTube videos. It's supposed to be y minus 5. I did it again. But hopefully now you're smiling and you're going, yep, I was right. I feel good about myself. All right, so there's the first equivalent fraction. Now, here's the second one, and you got to be careful, okay? You got to remember there's a minus sign out front. So what I'm going to do, all right, is I'm going to write a negative y minus 2 over y minus 5, all right? So there's this negative out front. And because there's a negative out front, what I'm going to do is I'm going to put it up in here in my numerator, okay? Now I know I want my denominator to look like y minus 5 times, y plus 4 times y minus 5. So I'm going to multiply by y plus 4 over y plus 4. Therefore, in my numerator, I have this negative out front, and I'm going to put y minus 2 and y plus 4. Okay? So if you notice here, you got a negative out front, which means in step 3, when you go to rewrite everything and simplify, when you go to rewrite everything, you're going to write y times a quantity, y minus 5, all over y plus 4 times y minus 5, minus the quantity y minus 2 times y plus 4, all over y plus 4 times y minus 5. And when you go to rewrite this, and this is where it is unbelievably important, and I'm going to put a big star here, okay? It's so important right here that when you write out your denominator and then you write out your numerator, watch what happens. We know in this step, you're going to have to distribute the y, but over here on the right-hand side, not only do you have to distribute all of this, but you also have to distribute that negative as well. So that little negative sign is going to ruin a lot of people if you do not write this step out. You got to be careful about this step, okay? So what I'm going to do here is just write LCD again, and I'm going to go ahead in the numerator and just distribute. So I get y squared minus 5y minus parenthesis. I'm going to put a big set of parentheses here. And then off to the right, I'm just going to move this over. I'm going to take y minus 2 times y plus 4. So I get y times y, which is y squared. Y times 4 is plus 4y. Negative 2 times y is negative 2y. And then I get that negative 8 down below. And when I combine all my like terms, that's already grouped together because I did the vertical addition method. I get y squared plus 2y minus 8. And this is what goes inside those parentheses. So y squared plus 2y minus 8. Let me just double check. Y squared plus 2y minus 8. Yep. And now I'm going to distribute the negative symbol. So this is going to give me y squared minus 5y minus y squared minus 2y plus 8. Now I group any like terms that I can. So y squared minus y squared, that goes to 0. And negative 5 minus 2 is going to be negative 7y plus 8. And then I'm just going to write my LCD, which is y plus 4 over y minus 5. Now I look in the numerator. Can I factor anything? Nope. So this cannot be simplified any further. And that is our final answer. Okay, so hopefully you can take away from this that these problems are not, they're not difficult. It's just they're really tedious, and you want to take your time. You don't want to rush through this, okay? I'm going to do a couple more examples here, and then we're going to move on into the next section, all right? So here's our next example. We got 2x over x squared minus 4 minus 1 over x plus 2. Okay? So step 1. Let's go ahead and factor. Let's find that LCD. So x squared minus 4 is difference of squares. X plus 2 times x minus 2. And then x plus 2 doesn't factor at all, so it stays x plus 2. I wrote an x plus 3. There we go, x plus 2. And now my LCD, just drop everything straight down. It's going to be x plus 2 times x minus 2. All right, so that's really simple. Step 2, we're going to build equivalent fractions. That's what that BEF stands for. I've wrote that a bunch of times already, so if you forget, just always scroll up, or rewind the video, I mean, not scroll up, but rewind the video. So my first fraction is 2x over the quantity x plus 2 times x minus 2. Remember, write it in its fractured form. I said fractured. Write it in its factored form, okay? Our goal is to get a denominator of x plus 2 times x minus 2, and it just so happens we already have that here. So we're just going to write 1 over 1 and call it a day. And that's a great thing when that happens. Now for the other fraction, you got this negative out front, so you got to be careful about that, all right? So I'm going to write negative 1 over x plus 2, and I know I need to multiply this by something to give me x plus 2 times x minus 2, and that something that we're looking for is x minus 2. So I'm going to write negative 1 times x minus 2. So here are my two equivalent fractions that I'm going to rewrite. So I get 2x over x plus 2 times x minus 2 minus 1 times x minus 2 all over x plus 2 times x minus 2. All right. And now I'm just going to write one big fraction with one denominator and one numerator. Okay. From here, I'm going to go ahead and distribute. So I get 2x minus x plus 2 all over x plus 2 times x minus 2. All right, that's going to give me, in my numerator, let's see here, 2x minus x is going to be x plus 2. And now, like I said, remember, you got to ask yourself, can you factor the numerator? Well, in this case, the answer is no. However, notice you have an x plus 2 in a numerator, and you got this x plus 2 in a denominator. There is nothing that says you can't put this in parentheses. I mean, you can do that as long as it's only by itself, which it is. So what I can do here is go ahead and reduce. The x plus 2's are going to reduce down into a 1 over 1. So what are you left with? 1 over x minus 2. So you got to make sure that you're taking your time with this. There's no rush. You don't have to rush at all. Okay? Nobody says you got to rush. All right? You just got to take your time with this. That's it. All right? I'm going to do one more problem here. I'm going to do one more problem. And this one, it's just going to be a big one. But you'll see. So the example was going to be negative 2y minus 2 all over y squared plus 2y minus 8 minus y minus 1 in the numerator and 2 minus y in my denominator. Okay? So before I do anything, there's something I see, and hopefully you see it because it's annoying me, and that something is right here. Notice in every single example, and I'm going to scroll up all the way up to the top basically. And every single example, if you look at my denominators, they're always going in descending order. Always. Even when I break them down, like right here, okay? The variable comes first, the number comes second. I did that in every single example. Look. variable first, number second, variable first, number second. Every single example. Okay? This is the first time. Man, I did a lot of examples. This is the first time where you get the number first and variable second, and I hate that. So what I'm going to do is just rewrite this. As negative 2y minus 2 all over y squared plus 2y minus 8 minus y minus 1 over negative y plus 2. Now, there is something else I hate now. This variable is negative. Now, normally, we don't like that variable leading term to be negative. If you need to scroll, or I said scroll again, if you need to rewind the video and look at all my variables, they're all positive. They come first and they're positive. So what am I going to do? Well, if you're thinking factor out a negative 1, this is exactly what I'm going to do. So watch this. Hopefully you're watching the screen. That's what I originally had, negative y plus 2. So when I factor out a negative 1, that changes the y to a positive, and then it changes the 2 to a negative. And then the last thing I see here is I got a double negative back to back. So because I have that double negative back to back, I'm going to rewrite the problem just one more time as negative 2y minus 2 over y squared plus 2y minus 8 plus y minus 1 over the quantity y minus 2. So what we had to do before we did anything was rewrite stuff and factor it out a negative 1. You will see this with practice, okay? So it's always nice that when you're doing your homework, maybe go in my video and try to find an example that kind of resembles it and then kind of model your problem off mine, all right? So finally, we could take a deep breath and go, all right, now we can do the problem. So step 1, let's find the LCD. Y squared plus 2y minus 8. We'll factor down into, let's see, a y and a y, a plus and a minus. And how about positive 4 and y minus 2? Now the y minus 2, well, that's already factored. You can't do anything with it. So I'm going to put it directly underneath. So my LCD, just drop everything straight down. So it looks like my LCD, and I'll highlight it for us. Let me use the thicker one. There we go. Beautiful. I really like that color. I think it's a nice color. So the LCD is going to be the quantity y plus 4 times y minus 2. Step 2, build equivalent fractions. So I'm starting off with negative 2y minus 2 all over, remember, factored form, y plus 4 times y minus 2. I'm going to multiply this by something, so I get y plus 4 times y minus 2 in my denominator. And guess what? I already have it. So it's going to be 1 over 1. And for this first fraction, nothing changes. Now, for the second fraction, it's going to be y, it's going to be y minus 1 all over y minus 2. I'm going to multiply this by something so that I get y plus 4 times y minus 2 for my denominator. If you compare, I already got the y minus 2. The only thing I need, y plus 4. So y plus 4 over y plus 4. So my new equivalent numerator is going to be the quantity y minus 1 times the quantity y minus 4. All right. Step 3, remember, is rewrite and simplify. All right, so negative 2y minus 2 all over y plus 4 times y minus 2 plus the quantity y minus 1 times the quantity y plus 4 all over y plus 4 times y minus 2. I'm just going to write the words LCD, and I'm going to write one big numerator. Negative 2y minus 2 plus the quantity of y minus 1 times the quantity y plus 4. So it looks like with this second half here, meaning over here, I'm going to have to distribute. So that's going to give me negative 2y minus 2. I still got this big LCD. The only thing I need to do is just distribute. Y times y is y squared. Y times 4 is plus 4y. Negative 1 times y is minus y. And then negative 1 times positive 4 is negative 4. So that's going to give me y squared plus 3y minus 4. So I get plus y squared. I already forgot it. Plus 3y minus 4. Notice, since that was a plus, I don't have to worry about distributing or changing signs or anything like that. So now I'm just going to group like terms. So I get an LCD. I get y squared up front. 3y minus 2y is going to be positive y. And negative 2 minus 4 is going to be negative 6. And I need to ask myself, can I factor that? And I'm going to tell you, yeah, you can. So let me write out my denominator. So that's going to factor down into, let's see here, a y and a y, a plus and a minus. Two numbers that multiply to give you 6, but combine to give you positive 1, and you know one of them is negative, the other is positive, is going to be plus 3 minus 2 equals positive 1. So plus 3 and minus 2. And if you notice, by me factoring, look what happened. You got a y minus 2 in the numerator and a y minus 2 in the denominator. And that will reduce down into the quantity of y plus 3 in the numerator and the quantity of y plus 4 in my denominator. And there's your answer. So I hope you found this informative. It's not difficult. There are just a lot of tedious steps. So if you need to, watch this video as much as you can. And good luck with the homework. I will see you in the next one where, honestly, it's much easier than this. It looks difficult, but it's really not. Okay? So I'll talk to you soon. Bye.